On January 13th, 2025, a piece of Antarctica the size of Chicago simply let go. It didn't explode, it didn't erupt, it didn't announce itself with any kind of warning that a person standing on the ice would have noticed. It just separated, quietly, the way a scab finally comes free from skin that has healed underneath it. Satellites caught it from orbit. Down on the surface, in the freezing wind of the Bellingshausen Sea, nobody saw it happen at all. And that single, silent moment of separation would end up exposing something that scientists still can't fully explain. The iceberg was named A84. It broke away from the George VI ice shelf, one of the long floating tongues of ice that hang off the edge of the Antarctic peninsula, holding the coastline together the way a shelf holds up whatever's stacked on it. When A84 slid free, it took with it roughly 510 square kilometers of solid ice, an area close enough to the footprint of a major American city that scientists reporting on the event reached for exactly that comparison. But size wasn't really the story. The story was underneath. For as long as that ice shelf had existed, it had been sitting on top of a stretch of seafloor that no human being, no camera, no instrument of any kind had ever been able to reach. Ice shelves like George VI aren't just floating on the surface. They're often hundreds of feet thick, and where they meet the seafloor, they seal off whatever's underneath as completely as a lid seals a jar. Nothing gets in. No sunlight. No falling debris from the surface. No easy access for a research vessel because there's simply no way to get a ship, or even a drone, into a cavity of water trapped beneath solid ice hundreds of feet deep. Scientists had drilled narrow boreholes into places like this before, lowering a camera down a hole barely wider than a dinner plate and hoping to catch a glimpse of whatever was down there. What they usually found, if anything, was a single creature clinging to a single rock, glimpsed through a single tunnel of light. That was the extent of what science understood about life sealed beneath Antarctic ice shelves. A keyhole view and not much more. A84 changed that instantly and almost by accident. A research vessel called the R/V Falker, operated by the Schmidt Ocean Institute, happened to be working nearby in the Bellingshausen Sea when the calving occurred. The team on board wasn't there looking for a hidden ecosystem. They were studying the broader relationship between ice and ocean in the region. But when word came that a section of the George VI ice shelf had broken free and drifted off, exposing seafloor that had been sealed for who knows how long, the crew changed their plans immediately. Patricia Eskeet, one of the expedition's co-chief scientists, later described the decision in blunt terms. They seized the moment, rerouted the ship, and went to see what had been hiding in the depths below. 12 days after the ice broke away, the Falker reached the site. By January 25th, they were floating directly above ground that had not been touched by sunlight or by anything else from the world above, in longer than anyone could say with any real confidence. They lowered a remotely operated vehicle named Sebastian into the water, built to withstand crushing pressure and total darkness at depths beyond 1,000 meters. When its lights switched on over the newly exposed seafloor, the crew wasn't looking at bare rock. They weren't looking at a lifeless graveyard, which is what decades of oceanographic theory would have predicted for a place cut off from sunlight for centuries. What the cameras found instead was a dense, layered, unmistakably thriving community of life, sitting quietly in the dark, waiting for nobody in particular, doing exactly what it had apparently been doing for a very long time. The first things that came into view were sponges, some of them large enough to be startling on their own. That size matters more than it might seem to at first. Sponges in these cold, nutrient-poor environments grow at an almost imperceptible rate, sometimes less than 2 centimeters a year. A sponge that size doesn't happen overnight, or over a single season, or even over a few years. It takes decades. In some cases, researchers estimated it could take centuries, which meant that whatever was living on that seafloor hadn't simply drifted in after the ice broke away. It had been sitting there, quietly building itself up, layer by layer, for generations, entirely out of sight, entirely unknown, while the world above went on with its business completely unaware. As the cameras moved further across the seafloor, more of the picture filled in. Clusters of anemones opened and closed in the current. Corals, some of them delicate and branching, stood in patches across the rock. Sea spiders crawled through the sediment, some of them unusually large, adapted the way many deep, cold water species are to living slowly in an environment where energy is scarce and nothing is wasted. Icefish moved through the frame, the kind of fish whose blood carries natural antifreeze proteins, allowing them to survive in water just above freezing that would stop the circulatory system of almost any other vertebrate cold. And somewhere in that footage, an octopus sat motionless on the seafloor, more than 1,000 meters down, in darkness and pressure that few animals on Earth are built to tolerate, doing what octopuses do best, waiting, patient and unbothered, as though it had always belonged exactly where it was. Since that expedition, researchers combing through the samples and footage have identified what they believe may be at least 6 species entirely new to science, organisms that had never been formally described or named before this expedition brought them into view. That number could grow as analysis continues, confirming A. New species isn't instantaneous. It takes careful comparison against everything already cataloged, DNA analysis, peer review, and often years of follow-up work before a name becomes official. But the early signs point to a community that isn't just unusually abundant. It's genuinely unfamiliar, holding organisms that don't cleanly match anything already sitting in the scientific record. What makes all of this so difficult to explain isn't just that life was there. It's that everything scientists thought they understood about how deep-sea ecosystems survive says this shouldn't have been possible, at least not in the form they found it. Across most of the world's oceans, life on the deep seafloor survives on what's often called marine snow, the slow, constant drift of dead organic materials sinking down from the sunlit waters far above. Plankton grows near the surface, feeding off sunlight the way any plant would, and when it dies, some fraction of it sinks, feeding the creatures living in darkness thousands of feet below. That relationship, sunlight above sustaining darkness below, is close to a foundational rule of deep ocean ecology. Cut off the surface, and eventually the food stops coming, and the ecosystem below it should slowly starve. But the world beneath A84 had been sealed away from the surface by more than 100 meters of solid ice for what researchers estimate could be centuries. No sunlight ever touched that stretch of seafloor. No surface plankton ever bloomed and died directly above it, raining down nutrients the way marine snow typically does elsewhere. By every existing model, that patch of ocean floor should have been close to empty. Instead, it was full. Researchers don't yet have a confirmed answer for how this ecosystem has sustained itself, and they're careful to say so. The leading hypothesis, which remains a hypothesis and not an established fact, involves ocean currents moving sideways beneath the ice shelf rather than nutrients falling straight down from above. As ice at the base of a shelf like George VI melts, it can release organic material and nutrients into the water. Instead of that material simply rising and dispersing into the open ocean, some of it may travel laterally, pulled by currents running underneath the ice itself, delivering a slow, steady trickle of nutrients sideways into the sealed cavity, rather than from directly overhead. If that turns out to be correct, it would mean this ecosystem quietly found a workaround to one of the most basic rules governing life in the deep ocean, feeding itself through a delivery system nobody had previously documented in this kind of setting. There's a strange and uncomfortable irony sitting inside that theory, if it holds up. If the ice sheet itself was slowly feeding the ecosystem beneath it, siphoning nutrients sideways through currents running along its underside, then the very structure that sealed this world away from sunlight for centuries might also be the reason it managed to survive that long in the first place. And if that's true, then the same event that finally allowed scientists to see this ecosystem, the calving of 84, may also have severed the mechanism that had been quietly sustaining it all along. Discovery and disruption, arriving in the exact same event. This wouldn't be the first time something like that has happened in Antarctica. Back in 2002, a much larger section of the Larsen B ice shelf, one that had remained stable for thousands of years, collapsed over the course of about a month. Scientists studying the area afterward found similarly established communities living beneath where the ice had been, and in some cases, watched as sediment and debris disturbed by the very same collapse that revealed the ecosystem began smothering parts of it in real time. Discovery and loss, occurring almost simultaneously, is not a new phenomenon in this part of the world. It's a pattern researchers have now watched play out more than once. Zoom out, and the scale of what remains unknown becomes almost dizzying. Scientists estimate that less than a tiny fraction of 1% of the global deep sea floor has ever actually been observed directly by cameras or human eyes, an area smaller than many U.S. states set against an ocean floor that covers most of the planet. In a very real sense, humanity has mapped the surface of Mars in more detail than it has mapped the bottom of its own oceans. If a fully developed, centuries-old ecosystem was sitting quietly beneath one patch of Antarctic ice, waiting for a single fortunate coincidence, a ship happening to be nearby when the ice broke, to ever be seen at all, it raises an obvious question about how many other hidden systems like it are sitting under ice shelves and deep ocean floor that nobody has ever had the chance to look at. The team aboard the Falcon understood they were working against a closing window. Once ice that has sealed off an area for centuries is gone, the conditions underneath begin changing immediately. Sunlight reaches the seafloor for the first time in what could be hundreds of years. Water temperature and circulation patterns shift as the surrounding ice retreats and currents reorganize around it. Whatever balance allowed this ecosystem to persist undisturbed for so long is no longer the same balance it existed within days earlier. Researchers plan to return to the region, with some expeditions already tentatively planned for the coming years, hoping to track how the exposed ecosystem changes now that it's no longer sealed away. There's also a broader scientific echo here worth sitting with. In 1977, researchers exploring hydrothermal vents near the Galapagos Islands discovered something that reshaped biology at the time: life thriving in total darkness, powered not by sunlight but by chemical energy drawn from the vents themselves. That discovery proved life didn't need a direct connection to the sun to exist and expanded permanently what scientists believed was required to sustain an ecosystem. What's been found beneath? The George VI ice shelf may turn out to be a related kind of proof, evidence that life sealed away in cold, sunless isolation for centuries can still find a way to persist, feeding on pathways nobody had fully mapped out before. That idea reaches even further than Antarctica. Scientists have long wondered whether oceans locked beneath the icy crusts of moons like Europa, one of Jupiter's satellites, could support life of their own, sealed away from sunlight in conditions that might resemble, in some rough way, what existed beneath A84 for so long. Nobody is claiming that what was found in the Bellingshausen Sea proves anything about worlds elsewhere in the solar system. But it does something quietly significant. It demonstrates, with real evidence gathered here on Earth, that isolation from sunlight and warmth doesn't automatically mean a place is lifeless. That single demonstrated fact may end up shaping where scientists choose to look and what they choose to expect the next time a spacecraft or a research vessel gets a rare, narrow window into a world that has been sealed shut for longer than anyone can measure. There's a practical urgency underneath all of this, too, one that goes beyond scientific curiosity. Marine biologists have pointed out for years that deep-sea ecosystems worldwide are being disturbed, damaged, or altered by human activity, from deep-sea mining exploration to shifting ocean temperatures, often in places that have barely been mapped, let alone studied in any detail. Recovery for slow-growing communities like the ones found beneath A84, built around organisms that take decades just to reach a few centimeters in size, can take generations if it happens at all. That means a newly identified species, discovered on camera during a single short expedition, could theoretically be lost again before scientists ever finish the process of formally confirming and naming it. The window these researchers had wasn't just narrow because of weather or ship schedules. It was narrow because the very thing that made the ecosystem visible in the first place, the calving of the ice shelf above it, may also be the thing that ultimately unravels it. This particular event also happened because a ship happened to be close enough and quick enough to reach the site less than 2 weeks after the ice broke free. That's not the usual case. Ice shelves along the Antarctic peninsula have been calving more frequently as the broader region loses ice, a trend tied to warming ocean and air temperatures over recent decades. Most of those calving events happen without a research vessel anywhere nearby, without a remotely operated vehicle ready to descend, and without a team of scientists positioned to document whatever gets exposed before conditions above and below the water start to shift. In those cases, whatever existed beneath the ice simply goes unrecorded, changing and adapting to its newly exposed circumstances with no one there to see it happen. For now, the samples pulled from that seafloor are still being analyzed, the potential new species are still being confirmed, and the questions about exactly what has been feeding this ecosystem remain open. What's certain is narrower, but still remarkable. For 12 days in January of 2025, a research crew got to look at something that no human being had ever seen before, a fully developed world that had been quietly surviving in total darkness, doing so by rules that science is still working out how to explain.